All right, team. My declare today is on averages. So I was in a conversation the other day about averages and why as I've gotten to be using more and more averages. So I use averages more and more now every day in my work. I've also been very cautious with what those averages are showing. And let me share with you why. And this might be as a surprise, but the set of pictures here, this clump of scattered plots, these lines, those lines, this X with the flares, the star, the parallel lines, all of these pictures, circle, spiral, circle thing, they all have the same average. Looking at them, you could see they're so different, but they all have the same average. And that gives you an idea of why there are some critical flaws with what the average, what the average is actually showing. And it's the intent of the average is to show central tendency. So if we had a normal distribution, right? Your bell-shaped curve, the average would be right there, and you could say that most everything happens between those 2 points. This is called the empirical rule. The problem that I have with averages, and I was telling a friend over the weekend, is if you have a logarithmic kind of exponential thing, the average is depending on how long this tail is and how long your exponential value is, the average could be anywhere within reason. But still, if the average is right here, that does not explain these points here. So much all of life is exponential. Much all of life can also be a bell shaped. The issue is that when you are presented an average, is it a bell shape? Is it exponential, or is it just sheer noise? I hope you found this educational and interesting.